All right, hello everyone. So today we are going to start with another topic, that is mensuration. So first of all, you should know that what actually mensuration is. So mensuration is a field of mathematics that involves the measurement of different geometric shapes. So it involves the measurement of different geometric shapes. It involves the measurement of different geometric shapes and their parameters. All right, and their parameters. Like, what are the parameters? Like length, area, perimeter, volume, surface area. Okay, so when we talk about shapes, few things comes to your mind. Might be it's a 2D shape or a 3D shape. So basically, let us start with a simple 2D shapes. All right. So when I talk about 2D shapes, there are different 2D shapes that comes to your mind. I'll start one by one with the basic 2D shape. So the first basic 2D shape is it's a square. All right. So let's make a square. So it is a square. So the very simple formulas, you know the formulas for the square. The very first formula is the formula for the area. So the formula for the area of square is L squared, and the formula for the perimeter of a square is 4L. That is length plus length plus length. All right. As the square has all sides equals, we're going to add length 4 times. That makes it 4L. All right. So basically, I think that you know that what's an area and perimeter. Area is the space that is inside a object, and perimeter is the measure of outer bound. Again, let me clear it. Area is something that is inside, and perimeter is the outer bound. So square, for the square, the area is L square and perimeter is 4L. Now, after square, let's talk about a rectangle. Let me just make a rectangle for you people. All right, so this is a rectangle, right? You know that this is breadth and length and breadth. So again, the area is the space inside an object and the perimeter is the outer boundary. So for area of rectangle, we have a formula length times breadth. And for perimeter, we have a formula L plus B plus B, right? As it has 2 lengths and 2 breadths. So it will be 2L plus 2B. Or might be, you can see somewhere like this, 2 times L plus B. So this is the square and then rectangle. All right. So for square, we have area L square, and for perimeter, we have 4L. And then again, for rectangle, we have area L times B, and perimeter is 2L plus 2B. Okay, let's talk about another shape, another 2D shape. That's a, let me just make it first. All right, so that is a triangle. Okay, now for triangle, the area is half into base into height. Now, so this is the base of the triangle and this is the height of the triangle. Now keep one thing in your mind very clearly, that height is always perpendicular to base. The height of a triangle is always perpendicular to its base. Now, let me just tell you another thing. For example, so this is, for example, this is a shape. All right. For example, this is a triangle. Let's suppose this is it. And let's suppose, all right. Okay. So let's suppose this is 6 centimeter and this is 4. So area would be half into base into height. So here the base is, let's suppose this is 4. So please don't get confused in it. Here the base is not 4, it is 6, because the height is 4 over here and height is always perpendicular on base. So this is the base over here, and this is the height. So height is always perpendicular on base. Please, every time when you have given the height, very clearly identify the height and the base in the triangle first, and then apply the formula. All right. Okay. Now let's talk about the perimeter. Perimeter is again very easy. It's just the outer boundary. So let's suppose this is, like, let me just use another color. Let's suppose this is A, this is B, and this is C. So perimeter would be A plus B plus C. All right. We have to sum up all the sides for perimeter. Perimeter is the sum of the boundaries. Okay. Now, let's just move to the next thing. Okay. Okay. Now, let's suppose, for instance, there's another formula also for the area of a triangle. Okay. So let me just make a triangle again. This is a triangle, right? So, for example, we have, let's suppose this is 4 centimeter. This is 6 centimeter. This is 30. All right. So area of a triangle equals to half into AB into sine of C, right? What is it all about? The included sides and the sides and their including angle. The sides and their including angle. All right. So it means that half into 6 into 4 sine of 30. So you can do like this also. So basically for area of triangles, when we have base and height given, we use half into base into height. And then for when we don't have the height given in the triangle, so we use the formula half into AB sine C, or you can say half into BC sine of A, or you can say half into AC sine of B. Let's just generalize it. For example, this is a triangle. This is A, this is B, and this is C. This is A, again B, and again C, right? So these all formulas are applicable on these triangles. But be very careful that you just have to take the two sides and the included angle like this. Again, the two sides, A and C, and the included angle. Again, the two sides, A and B, and the included angle. Like the way we have discussed over here. Half into A, B, the two sides, and their included angle is C. So we are done with it. Again, half into BC, B and C, and the included angle is A over here. We're done with it. Again, half into AC, and the included angle is angle B over here. All right. So we're done with square. We're done with rectangle. We are done with triangle. Triangle area and perimeter both. Right? So now let's talk about another 2D shape that is a parallelogram or a rhombus. You can say both are about like same. Okay, let me just make a rhombus, and again I can make a parallelogram. Okay. All right. So rhombus is basically a tilted square, and parallelogram is basically a tilted rectangle. So this is a rhombus. This is a parallelogram. So rhombus is a tilted square and parallelogram is a tilted rectangle. So the formula for the area of rhombus is equals to base into height. Again, I have discussed it very clearly that height is always perpendicular on base. Height is always perpendicular on base. So this is base and this is height. So the formula for the area of rhombus is base times height. And again, the formula for the area of parallelogram is again base times height. So area of parallelogram is base times height, right? So area of rhombus and parallelogram both have formula base times height. And then again, for perimeter, as perimeter is the sum of all the boundaries, the sum of outer sides. So we are going to sum all outer sides for the perimeter, right? I hope it's quite clear to you. Okay, now let's talk about the other 2D shapes since we are just working on the 2D shapes right now. So let us just talk about another 2D shape. So the next 2D shape is, it's a trapezium. All right. It's a trapezium. Okay. So the next 2D shape is trapezium. We can make a trapezium like this also. We can make a trapezium like this. This is the height. Again, height is always perpendicular in the base. So whenever we talk about trapezium, you should know that it has a pair of parallel sides. It has a pair of parallel sides. Normally in exams, you can get the trapezium like this also. So please don't get confused with it. Just identify the parallel sides first of all, whenever you see the trapezium. Just identify the parallel sides. Once you identify the parallel sides, so it's very easy for you to find out the area of trapezium, that is half into the sum of parallel sides into height. Half into the sum of parallel sides into height. So the formula for the area of trapezium is half into sum of parallel sides into height. These are the two parallel sides, A and B, right? Okay. Now again, for perimeter of trapezium, that is sum of all sides. Sum of all sides. Okay. Now, so we are done with trapezium. All right. Now, let us just start with a circle. So let me just make a circle first, and then we will start with it. So this is a circle. Let us just start with the circle. Okay. So for circle, first of all, you should know this is a center, right? And a diameter is a line that passes through a center, exactly dividing the circle into two equal parts. Radius is the half of diameter. So the radius is the half of diameter. This is R and this is D. Okay. So this is D. The formula for the area of circle is pi r square. That is pi r square. And the formula for perimeter of circle is 2 pi r. This is 2 pi r, right? So how can you get the value of pi? Okay, there is on the calculator, there's a shift button, and then in the last row, there's a button in the middle. So shift and that button gives you the value of pi. Okay, so after a circle, let's talk about a semicircle. So semicircle. All right, this is a diameter, right? And the half of diameter is radius. Okay, so as semicircle is the half of a circle. So for the area of semicircle, it is pi r squared divided by 2. Now, normally students make mistake while finding the perimeter of semicircle. Please don't get confused with it. As I have discussed with you that perimeter is only the outer boundaries. The distance is just the outer boundary. So if you see this figure, this semicircle, this is the outer boundary, this curve and a diameter. So there are two things that needs to be added for the perimeter of a semicircle, right? This curve and a diameter. So as you know, the whole circle has a perimeter, or you can say circumference also, is of 2 pi r. So this half would be 2 pi r divided by 2 plus diameter. Again, whenever we talk about the perimeter or the circumference of semicircle, just keep this shape in your mind. This shape, that's it. This half curve and a diameter. The half curve, that is 2 pi r over 2 and a diameter. this half curve that is 2 pi r over 2 and a diameter. So finally, we got the formula pi r plus d for the perimeter of a semicircle. We got the formula pi r plus d for the perimeter of the semicircle. All right. Circle, that is pi r square, the area. Semicircle, that is pi r square by 2, right? Okay. Now, the perimeter of a circle, that is 2 pi r. The perimeter of a semicircle, that is 2 pi r over 2 plus d, or pi r plus d. Okay. Then, obviously, quadrant. So, quadrant is a fourth part of a circle. Quadrant is a fourth part of a circle, right? So, this is r. Okay. So, area of quadrant, it would be pi r square over 4. So the area of quadrant would be pi r square over 4, right? Area is basically very easy. Just keep the area of circle in your mind, that is pi r square. And for if it's a semicircle, that is pi r square over 2. If it's a quadrant, that is pi r square over 4. Now, let's talk about a perimeter, or let's talk about a perimeter of quadrant, as it's a outer boundary only. So, okay. So it means that this, that is r, plus this, that is again r, plus this curve. Okay. So, you know, for the circle, the circumference of the perimeter is 2 pi r. So it means that for the quadrant, it means 2 pi r over 4 would be this curve. 2 pi r over 4 would be this curve, plus r, because there are 3 boundaries, 1, 2, and 3. So 2 pi r over 4 plus r, right? I hope it's clear. Okay. Now, so it will be pi r over 2 plus r and r. As you know that 2r can make 1d also. So you can use it like this, pi r over 2 plus d, or pi r over 2 plus r, right? Clear? Okay. Let's move to, okay, let's just recall it once again. For circle, the area is pi r square. For semicircle, it is pi r square over 2. For quadrant, it's the fourth part of a circle. So it's pi r square over 4. Okay, for perimeter of a circle, it's 2 pi r. For semicircle, it's 2 pi r plus d. And for quadrant, it is pi r over 2 plus d. Let us just start with sectors now. Another thing. Okay, so let's just start with sectors. Okay. So basically, what is a sector? A sector is a part of a circle made of the arc of a circle with its 2 radii. It's a part of a circle made with the arc of a circle and its 2 radii. Let me just show you first. So this is a circle. Okay. So how a sector is made? How a sector is made? It is made with an arc of a circle with its 2 radii. So let's suppose this is 1 radii and this is another radii. So this is a sector. It is made with an arc of a circle. Let me just clearly explain you once again. An arc of a circle with its 2 radii. So it makes a sector. An arc of a circle with its 2 radii. It makes a sector. Okay. Okay, now this is called a minor sector. It's small, and this is called a major sector. Let me just write it. Minor sector and major sector. Okay, you can just recall it, or you can just remember it with this like thing. It looks like a pizza slice. So you can just remember it with a pizza slice, and the other one, it looks like a Pac-Man. So you can just remember it with a Pac-Man. So it's a pizza slice and a Pac-Man. Okay, so this is all about sector. Now, obviously, we have to see that what's the formula for the area of a sector and a perimeter. Okay, so for the area of a sector, for the area of a sector, we have a formula theta over 360 times pi r square. Theta over 360 times pi r square. Theta over 360 times pi r square. Now, be very careful that either we are finding the area of a minor sector or a major sector. Sometimes, and what happens that this angle, let's suppose, is given, okay, 60 degrees, and he says you to find out the area of a major sector. So for the area of a major sector, we're not going to put 60. We're not going to use this 60 angle. We are going to use this angle, right? And you know the complete rotation is of always 360. So this angle would be 300. So area of major sector, for area of major sector, you're going to use 300 degrees. And for area of minor sector, you're going to use 60 degrees. All right. So we have area of major sector and minor sector, right? Now let us talk about the perimeter of the sectors. So for the perimeter, again, what we have to do, we have to move through all the outer boundaries. So this is the outer boundary, arc length plus radii and radii. As in the very start, I have told you that how does a sector form? It is formed with one arc length and two radii. It is formed with one arc length and two radii. So for perimeter of sector, what we can do, what we have to do, arc length plus arc length plus R and R plus R and R. Now, question might comes to your mind, and it is definitely coming to your mind, that what actually is arc length and how can we find out the arc length? Yes, we have a formula to find out the arc length, that is theta over 360 times 2 pi r. Theta over 360 times 2 pi r, right? So do not get confused in arc length and perimeter. Perimeter is that you have to add up all the outer boundaries. And the arc length is very simple. It's the length of one arc. That is theta over 360 times 2 pi r. Okay. For area, we have theta over 360 times pi r square. And for arc length, we have theta over 360 times 2 pi r. Theta over 360 times 2 pi r. I hope it's clear to you. All right. Now, so we are done with the sectors, right? We are done with the area of a sector and we are done with the perimeter of a sector. For sectors, we have the minor sector and a major sector. The minor sector looks like a pizza slice and a major sector looks like a Pac-Man. For the area of minor sector, we have to cater the angle of a minor sector. For the area of major sector, we have to deal with an angle of a major sector. For the area of minor sector, the formula is theta over 360 times pi r square, right? For the area of major sector, again, the formula is theta over 360 times pi r square. But theta would be different for minor sector and major sector. Now, another thing, let's talk about what a segment actually is. Okay, so again, let me draw a circle. So this is a circle, right? This is a circle. So if I draw this line, it's not the diameter because diameter always passes through a center. So it's a chord. A chord again divides a circle, but not into two equal parts. It divides a circle into two parts, right? So we got two segments in this way. This small one is known as the minor segment. And this is the major segment. Minor segment and major segment, like the minor sector and a major sector. But sector and segments are different. Sector and segments are different, right? So now we can find the area of the segments, minor segment and major segment. Let us discuss just one general example. So this is a question that comes in the paper. Let me just draw it first. Okay. Let me just draw it first. In the exam, question comes like this. This is a circle, right? This is the center. All right. Let's suppose this is 60 degree. Okay. Now identify the minor segment here and the major segment. So this is the minor segment and this is the major segment. Okay. So let us suppose question comes that find the area of a minor segment. Now, for the area of a minor segment, this is the minor segment, right? Now just think about it, that what actually this is. We have discussed right now that what actually it is. It's a sector. Very good. It is a sector, or you can say it's a pizza slice. So area of a minor segment will be area of pizza slice minus area of pizza slice minus area of triangle. Obviously, when you, from this pizza slice, from this sector, when you will subtract this triangle, you'll get a minor segment's area, right? You'll get the area of a minor segment. From this pizza slice, when you will subtract this triangle, see, from this pizza slice, when you will subtract this triangle, you get the area of a minor segment. And area of pizza slice, you know that how to find out area of a sector, and area of triangle, you know that how to find out the area of a triangle. Okay, let me just do it for you. Oh, fine. Let's suppose this is 8. Okay, let's suppose this is 8. Okay. So area of pizza slice would be, come on, yes. Area of pizza slice would be theta over 360 times pi r square. Okay. And area of triangle would be, yes. So here we'll not cater the formula half into base into height because we don't have any height over here. So half times 8 times sine of 60. In this way, we can get the area of a minor segment, right? Let's just discuss it once again. Area of a minor segment would be area of this pizza slice minus area of a triangle. Okay, now how to find out the area of major segment? Area of major segment. First of all, identify the major segment. Where is the major segment? Identify where is the major segment. Okay, ji. The major segment is this all. This is the major segment. This is all the major segment, right? So for this major segment, yes, how can we find out the area of a major segment? That would be the area of, yes, what is this? Area of Pac-Man plus area of triangle. Area of Pac-Man plus area of triangle. Area of Pac-Man plus area of triangle. For area of Pac-Man, we have theta over 360 times pi r square plus area of triangle again half times 8 times sine of 60. Okay. Right. Now, what do you think that the both thetas, will it be the same? No, they won't be same. For area of minor segment, we have to use theta 60, and for area of major segment, we have to use theta 300, as this is 300, right? The whole rotation is of 360. So in this way, we can find out the areas for the minor segment and the major segments. All right. So we are done with the 2D shapes, right? We are done with the 2D shapes. So for 2D shapes, we are done with squares, we are done with rectangle, we are done with triangle, we are done with parallelogram, we are done with rhombus, we are done with circles, semicircles, quadrants, sectors, and then segments. In the next video, I'll be discussing all the 3D shapes.